Okay, let's talk about finding intercepts and graphing. Now, before we can start by calculating intercepts, we first need to understand what an intercept is. Okay, I have a coordinate graph. On my coordinate graph, I have a y-axis and I have an x-axis, or a x-axis, excuse me. Now, let's draw a line. Okay, this would be a linear graph, okay, because it's a straight line. Now, I can see my graph crosses at my two axes. So these points would be considered my intercepts. Okay. We can see when we have an x-intercept, we can see that our y is equal to 0. How do we know that? Because there's no upwards or downwards shift. Okay. The line is at 0. What about my y-intercept? My y-intercept, I can see that my x is equal to 0. Okay, because there's no left or right shift or horizontal shift. So in a case like this, to identify our intercepts, we just need to look where our graph crosses our y. But let's say, for instance, they give us this type of example. Y is equal to 2x plus 2. They give us this equation. Now, by looking at this, I can say, or I can tell you that this is a slope-intercept form equation. If I had to graph this, it would look something like this, but we'll discuss this in another video. I'm gonna start at my y-intercept, which is 2. I'm gonna go 2 up and 1 right. My rise over run, so 2 up, 1 right. So this is how my graph is supposed to look. Okay, I can see it crosses at my y, and I can see it crosses at my x at this point. But now we have no idea what those points are. And this is where intercepts come into play. So let me rewrite that equation. It's going to be y is equal to 2x plus 2. Now, to calculate my x and my y intercept, to calculate my x and my y intercept, I'm going to set my y equal to 0, because we've already discussed this, right? Which just makes logically sense, right? If I change it to any other value, it won't cross where my y is equal to 0. So in this case, I'm just going to simply write 2x plus 2. I made my y 0. Okay. Now I'm going to subtract 2. I'm going to subtract 2 on both sides. Subtract. So I'm left with 2x is equal to negative 2. That will give me x is equal to negative 1. If I divide with my coefficient of x. Now I'm going to do the same thing for my y-intercept. I'm going to simply replace my x, in this case, with 0. So y is going to be y plus 2. That's going to give me y is equal to 2. Now it's very important we can rewrite our coordinates as where my x is negative 1, my y is 0. And where my y is 2, my x is 0. Remember, when we write coordinates, this would refer to my x coordinate, and this one would refer to my right coordinate, or my y coordinate, excuse me. Now, let's graph these two. So I'm going to draw another coordinate plane. I'm going to go negative 1, 0, which is about here. I'm going to go 0, 2, which would be above there. And when I add these two intercepts together with a straight line, I can then pretty much see that this is the same graph I got by following my slope-intercept form, using a slope, which would be my rise over run. So this is how we can use intercepts to graph graphs, to find certain points where the linear function crosses. We can do this with all sorts of things, but slope-intercept form I will discuss in the next video.